optimization, what we are trying to do.
My name is Marco Gramaglia. I'm from University Carlos III of Madrid. And as Peter said, I'm going to present some of the concepts that we're currently investigating in the framework of the 5G NORMA project, more specifically the Work Package 5, where I am the Deputy Work Package Leader. And as I said, I will present some new concepts on the software-defined network control and the orchestration. I will again introduce some of the concepts you have been seeing during these 3 days of summer school, but please forgive me if some of them are already well known, but I think they are important for introducing the novelties we are currently investigating here. So I start with a slide which, okay, I have a problem in here, but with a slide which is the NGMN one, where they define the KPI needed for the future 5G networks. This is not just important for the KPIs, but it's important because we would like to introduce the scope of the project 5G NORMA, which is not just increase the KPIs currently provided by 4G, but also enabling new businesses, introducing a new level of flexibility that allows mobile network operators to deploy and run new services on demand and provide the capabilities that they can use to do that in a cost-efficient way. So, as the title of the slide says, we are not just adding 1G to 4G. It's not just enhancing the old architecture, but restructuring it and introducing novel concepts in order to provide these new capabilities. So at UC3M, we did this exercise, let's say, to check what are the goals or the requirements that are currently being envisioned by the different standardization body, 5GPP, the Asia and America 5G organization, which they are more or less the same, and they are resuming the right-hand side of the slide. And then on the left-hand side of the slide, we have the enablers, the technologies that were proposed during the recent years, and on top of which future 5G network will be built. So we link them with the cause relationship effect, and we emphasize the ones we are currently investigating in 5G NORMA. And you can actually see that despite probably focusing on very few enablers, which we found very important for the scope of the project, we are actually addressing all the requirements. So it's not we are going to provide novel algorithms and techniques that can help to get all those enhanced KPIs as defined by the standardization entities. And by doing that, we are going to introduce into our architecture new concepts that are very that will be very well integrated into the new architecture. As I said, some of them are you already familiar with because they were named here a number of times. But this is the overview of the technologies. The key word here is flexibility, because as I said, we would like to obtain with this new architecture a flexible architecture that is capable of providing new services on demand and in a cost-efficient way. So this will be the outline of this talk. I will follow this scheme I was presenting before. So I will start with the goals first, what we would like to achieve with the network. Then I will describe briefly the enabler, what will allow us to get to that point. And then the 5G NORMA specific that allows us to do that. The architecture, the controller, and the orchestration. And then I will conclude. So we start with the goals, what we should achieve with 5G networks. Basically, as I said, it's enabling flexibility. We would like our network to be flexible, to support very heterogeneous in terms of KPIs services. So our network should be flexible. And in order to do that, we build on these three concepts. The software-defined mobile network control, that is applying the concepts that were first proposed by SDN to all the network function in a mobile network. The adaptive decomposition and allocation of mobile network functions, so a monolithic architecture where network functions are statically deployed is not enough to support very different services. So our proposal here is to do that in a flexible way. For some service, we are deploying network function in a different way than other services in order to achieve the required KPI. And the joint optimization of mobile access network function and core network function. With the previous point, we are now moving around network functions, so we deploy them where we get the most out of them. So they are actually now located probably closer rather than in the traditional architecture. So we can actually improve them in order to take optimal decision in a way that wasn't possible before. And why we do that? Because our network should support multi-tenancy and should support context awareness. So the network should support multi-tenancy because we would like the network to be cost efficient. So it should be shared among different tenants that can then run on top of it different services, for example. So our architecture should be able to support different services belonging to different tenants, and should be, as I said, context aware. So it should be adaptively reorchestrating and reoptimizing it if the load is changing, if the conditions are changing. So it should be flexible in that way. It shouldn't be as monolithic as it is right now with the current architecture. So in order to do that, we introduce into our architecture these two novel concepts, which you already heard in these 3 days, network slicing and network programmability. So network slicing is the capability, I will go briefly through this point because you're already familiar with after these 3 days. Network slicing is the capability of being able to support different end-to-end network belonging to different tenants and services on the same infrastructure. And network programmability is the extension of the SDN concept. So instead of having a distributed approach, we have a centralized approach where we can actually program all the function in the network using SDN and NFV technology. So network slicing is useful for obtaining multi-tenancy, while network programmability is useful for context awareness. We can adapt it by reprogramming the network. The advantages of network slicing are cost reduction. A very naive way of obtaining network slices is actually to deploy to different networks, but we would like to do it using the same infrastructure, so we can have a cost reduction and we can have a logical separation of services. While for context awareness, the advantages there are on-demand provisioning, so we can actually provide more resources when they are needed, where they are needed, so we can actually support the specific KPIs needed for a specific service. Of course, these come at a price. That is a research price in this case. For network slicing is the efficient resource sharing. As I said, different services will run on top of the same infrastructure. In the end, they will share some of that infrastructure. The most straightforward example is spectrum. They will end up using the same spectrum. So we have to find a way to share this resource among different slices in a fair way. And for network programmability, the challenges there are the interface definition, because in order to get the most out of the network programmability approach, you need to use a standardized interface in order to be as interchangeable as possible, and the resource abstraction, how to actually abstract the resources you have in the network in order to perform orchestration and control. So in the framework of WP5, we are actually tackling these two new concepts by proposing new technologies. I divided here them according to their realm, let's say. So for network programmability, we have to provide the monitoring of the QoS and the mapping of the quality of experience to the QoS parameters. This is important because in the end that is what the end user will feel. So we need to have a fine-grained QoS monitoring in order to recognize that the network slice is running well, and we need to have a QoE to QoS mapping module in order to understand what is the correct QoS that should be provided to a user in order to achieve a target QoE. From the network slicing world, we are currently working on the mobility scheme selection. This is better explained with an example. If I have a network slice that will support IoT, I probably don't need any mobility management scheme. While if I like to support in a network slice a vehicle-to-vehicle service, then I will probably need to have a very tailored mobility management scheme. So that should be an important part of the network architecture. And then there are some of them that are mixed among these two words, that is the software-defined mobile network control. More details about that will come afterward. We actually define three actors here: the controller, that is performing the network control within a network slice; the coordinator, which takes care of the sharing of the resources among different network slices; and the orchestrator, that is an extension of the XCNFB MANO architecture. How they are linked in this way? We basically divided them into three big blocks that are, from one side, the mobility management, which is kind of separated from the rest of the blocks that are related to the network slices. The intra-slice management, where we manage everything happening inside a network slice. So we have the software-defined mobile network control and the mapping and the monitoring of QoS. And the inter-slice management. On the same infrastructure, we have different network slices, so we need to orchestrate the resources in a fair way among them. So we have those two blocks, the orchestrator and the coordinator. And you can see also they have different interfaces among them in order to provide the standard functionality of a mobile network. So we have seen the goals, what we should achieve with the network. Now I'll go briefly into the enablers, what will allow us to get to those goals. Again, this is a brief research I've done by looking at the number of scientific articles that were dealing with SDN and NFV during the last years, and we see that there is an increasing, this is actually an increasing emerging trend. So in the last 10 years, the number of papers talking about SDN went from 0 to 1,500. So there's actually a lot of interest in this field because it's actually joining two worlds that were kind of separate the previous year, the telecommunication and the IT. We are actually merging them into the same architecture with SDN and NFV. So we are actually moving from, by using those two technologies, we are actually moving from a network of entities where we have fixed pieces of hardware deployed inside the network to a network of function. I don't care anymore about where a network function is placed. I care about what we can achieve with that. So I can, using NFV and SDN, I can actually route the traffic to it, so I can deploy it in the best way I need. We are moving from specialized hardware, those big boxes that were specially tailored for a specific function, to generic purpose hardware. We have x86 processors, and we run all the network function on top of it. So we have this level of flexibility. So this also has an impact on the hardware network vendors that now are going to be software vendors, because before they had a very big effort in joint software hardware design in order to get to squeeze every bit of the of the hardware they had in order to obtain the highest performance. Now they are moving with this virtualized network, this softwareized network. They are moving to be actually software vendors. So they have to provide added values through software, not through hardware anymore, or at least in a different way. So very briefly, as I say, we are leveraging on SDN and NFV. So this is briefly SDN, where we have the split between the logic of the application and actually the physical resources that are carrying out this application. So the most straightforward example here is switching. So we have the application logic on top of the controller that says, okay, I would like this flow to be routed through this port, and then you have actually the switch, the other switch that is performing this operation. So we are actually splitting these two parts, and that allows us to control a network function that was embedded before in a very different way. Then I will propose new extension to this architecture, and this is part of what we are doing in 5G NORMA. And here, this is the other enablers. The other enabler we have in 5G NORMA, that is NFV. So, as I said, we are moving from a very static entity that was a big hardware box running a very specific running a very specific software that was tightly integrated with the hardware, to this architecture where we can actually run any kind of network function on top of generic hardware, and we can actually obtain economy of scale, because we can use higher and more powerful generic hardware, so we can reduce cost by centralizing all the network function into a single data center that is more efficient than running it in a distributed way, where you need where you go into higher cost for maintenance and so forth. So we actually build on top of these two technologies, but of course, as we were seeing in the first slide of this part, there is already a large number of work going on in these two topics. So there is already state of the art in this field. So the most relevant for the scope of 5G NORMA is the concept of Cloud Run and the concept of Run as a Service. The second one was proposed by the European project IGEN. So with the C-Run concept, what you're actually doing is, okay, I don't want to have static e-node-Bs in the edge of the network anymore. I will centralize everything in a centralized data center by using SDN and NFV. With that, you can actually have, as I said, economy of scale, because you are centralizing the processing capacity. You can actually go one step forward and go to the Run as a Service scheme, in which you can actually split the run stack into different points, and then select to move some of those functionality to the center of the network and leave some of them to the edge. I think Mark described with a lot of details these approaches yesterday. The point here is that those are fixed. So what they were proposing was a fixed architecture, in this case with the centralized processing of the wireless network function, and a fixed location of network function for the run as a service. So once you decided to split, you use it for everything. That is good, but it's not enough for us. So what we are currently doing is to leverage on SDN and NFV, introduce the concept of network slicing and network programmability, because they were allowed by those new technologies, and execute these three novel actors that we have in networks, the SDMC, SDMO, and SDMX. So we can actually achieve some of the goals we were describing before, the reduced service creation time, the improved cost efficiency, and the enhanced mobility. So now I'm stepping into what we are currently researching in 5G NORMA, and I start with the architecture. As I said, run as a service is a very good idea, but it is not enough for us. We'd like to add one more level of flexibility. So we build on this idea that we probably need different deployment for different services. So if a network slice is devoted to internet access, the users are probably less sensitive for delay, so I can actually push all the network function U and C plane for core and run to the center of the network, so I can have multiplexing gain and can reduce the cost for the economy scale. While if I have a very challenging network slice in terms of KPIs like haptic internet, as we were discussing the first day of the summer school, I will probably need to run most of the network functions in the edge of the cloud in order to reduce latency, but as I need session continuity, I will need to still have a part of the core network to be run in the center of the cloud. While if I have vehicular communication, I probably don't need session continuity, so I can actually push all the network function towards the edge of the network. And our architecture is built to support that. How we do that? With those three actors, as I said. SDMC, that is the acronym for Software Defined Mobile Network Controller. Its main goal is to apply softwarization to all the wireless control functions. So, as in SDN, where we actually programming the forwarding of packets using switching, here we are proposing to apply this concept to all the network functions in the network, not just packet switching. And, most important, also to wireless control network function, the scheduler, for example. So we are actually studying how to apply the same concept, which is a good concept, to all the network function, also the wireless one, inside the network slice. And of course, it manages all the resources inside the network slice. The SDMX, the software-defined mobile network coordinator, takes care of actually performing the fair sharing of resources between network slices. If you control a network slice belonging to different tenants in a selfish way, you will end up having a suboptimal result. So we need this module that takes care of optimizing the resource request and the control performed by the SDMC, a fair sharing of the resources within a network slice according to some policies that are set by the service provider. So, as I said, the most straightforward example is spectrum, but also other functions can be controlled in this way. And then finally, the SDMO, the software-defined mobile network orchestrator, that provides the efficient orchestration of network function in a network slice and the optimal resource assignment for all the network slices. So you need to, for CPUs, memory, and this kind of resources, you need to have an enhanced orchestrator for that. This is how they are actually placed in the 5G NORMA architecture. I think Christian already explained in details what they are actually performing inside the networks, inside the 5G NORMA architecture with the SDMO that is actually connected to some of the elements that are currently being used in the mobile networks. And this is the life cycle of a network slice. As all the mobile network, we need to support the left-hand side part of the scheme, where we are continuously evaluating the QoS in the network slice, and eventually we are reshaping it if some of them are not met. But then we need to add also what we have here in the left-hand side of the picture, the kickoff of the slice with the resources assigned to it, and the slice creation request when a tenant comes to the service provider asking for a new network. As the standard, the legacy mobile network architecture, we have control plane and user plane. And as we are designing SDMC and SDMX to actually split these functionalities, they are the border of the control plane, which we call logic, and the user plane of the network. So we have SDMC application on top of the SDMC, and policies on top of the SDMX, and different plugins that are used to control different elements of the networks. So it can be open flow, for example, if we need to steer traffic, or vendor-specific plugin if we need to control a very specific network function. So this allows me to explain the concept of flexible controller, that is network control beyond the SDN concept. So as I said, we would like to get the same concept of SDN also to functions that are not forwarding. So as it is explained in the picture, with SDN we split forwarding and routing. So we program routing and we let the switch perform forwarding on the subman interface. The 5G NORMA we would like also to control wireless network function in the same way. So split the wireless control function, and of course also the data one, into logic and agents. So we can actually program the agent to control, to program the logic to control the agent. So we can achieve the same advantages provided by SDN also with other kind of network functions. So with an example, if here we have this kind of network with the edge cloud and the central cloud controlled by the SDMC, and we have this scheduler with this assignment of resources. When two, for example, vehicular users are coming, by using the flexibility of SDMC, a new policy can actually be forced to the scheduler, because we recognize that UE1 and UE2 are actually vehicular users, so they probably need very low latency. So we can control this part of the scheduler and reshape it in order to obtain a service-aware scheduler. So that is the concept explained with this kind of example. Of course, this allows us also to sort out other problems. We actually get rid of all the complexity of introduced by a specific vendor, because it's handled on the software interface. And the development of this kind of application is actually simpler because it uses a standardized interface. The VM migration of network function on the data path is less critical, because we just need to reprogram the SDMC application. And the optimal decision taken in network function it's actually easier to take optimal decision, because as they are controlled by applications that are running very close in the network, they can actually talk among them and then taking optimal decision. For example, mobility decision and scheduling can be jointly optimized. As an SDMC application, it's like an SDN application where we split the logic from the agent, but the scope is broader. So we would like to target other control functions like scheduler or interference control. In general, what we would like to achieve is to have all the network functions in a mobile network to follow this approach. For example, for mobility management. So we can actually, with this toy example, we can see that we can actually have on top of the SDMC a mobility management application that processes new attached requests, the QoS status of the network, new requirements required by the tenant for user, and controls the network by setting forwarding paths and tunnel endpoints, of course with the help of the orchestrator. So the idea is manage the barrier setup with this kind of application. We have more of them. We can have a video-aware pre-scheduler. So by controlling this scheduler using this kind of application, we can actually detect what are video flows. So we can actually tell the scheduler to assign the resource blocks to those flows in a different manner in order to achieve an enhanced QoS compared with the current approach, which is GBR and non-GBR. We can have interference control using the same approach. If I know that video flows are actually using the network, I can actually program and control the interference control to be more careful with those flows, because they are very sensitive. So we can actually provide this kind of flexibility we need for this kind of traffic. And here comes the second point of the controller, the SDMX. In the end, network slices will share network function. Spectrum is the most straightforward one. Here we have an example of network slices asking for spectrum resources. We need a module, in this case SDMX, that arbitrates the request and assigns to each network slice the correct amount of resources. Spectrum is the most straightforward one, but we may have others like HSS, for example, or we can go one step up by sharing the log scheduler, for example. The problems here are how to do that in an optimized way. So we are actually dealing with it as an optimization problem, taking into account several parameters: throughput, latency, error recovery, and reliability. Of course, you need to find the good point, the good trade-off between the redundancy of the computing resources, for example, and the cost efficiency. And all of them should be optimized by taking into account different tenants in the network. So the last point is the optimized orchestration. So we have the control and softwareization of the network from one side, and from the other side we have the orchestration. So we actually need more capabilities compared to the standard orchestration for cloud computing, because probably with cloud computing you just care that some specific functions are not assigned to the same availability zone. So if a data center is set on fire, you can actually recover your service. With orchestration for NFV, you will actually need to take into account network constraints. So you actually need to fulfill QoS constraints between network functions. So latency and guaranteed throughput. So the orchestrator should be able to perform these functionalities. We are actually leveraging on the concept of SFC, service function chaining. So here the SDN network is used to actually route and steer the traffic through different network functions according to a classifier. So a video user may go the flows of a video user may go through a video optimizer. This is actually envisioned by the SFC working group by using it just in the core part of the network. In 5G NORMA, we would like also to enable it in the run part. So not just in the core of the network. So this is a basic template of what the orchestrator should do. We get some service request with a definition of SLA needed by this request. We actually create a service request that builds on network function chain templates. Once we decide what a chain looks like for a specific kind of service, we send them to the orchestrator that then allocated the needed resources and then kicks off these dice. So this is the architecture currently proposed by SCNFV, where you have the network function, the physical resources, and the intelligence here that is provided by the orchestration, the orchestrator, the VNF manager that provides the lifecycle capabilities and the elasticity, scale in, scale out, scale down, and scale up, and the Vim. We are in 5G NORMA, we are building on top of this definition and enhance it in order to support programmability and network slicing. So in order to do that, we still have to support these basic functionalities that are needed by an orchestrator for NFV. This lifecycle, instantiation and termination, failure management and migration, and the elasticity. So scaling in and out, adding or removing virtual machine from the VNF chain, and scaling up down. so increasing or decreasing the resources associated to VMs. And we are going to do it by taking into account QoS parameters of the network. So the orchestration will not just check if a VNF has enough resources, but it will do it by taking into account the QoS associated to that VNF chain. So we are going to manage all this functionality in the SDMO. So this is the concept of the SDMO. It is split into two submodules: the Internet Slice Broker that processes the request, builds the network function chain and the requirement, and passes it to the intra-network slice orchestrator that actually allocate the needed resources. Some of them can be dedicated just for a specific network slice. Some of them can be shared, for example, spectrum, and we are going to control it using the SDMX approach as we have seen before. Of course, we need to tackle some research problem here, how to perform DNF chaining and routing. So I have a DNF chain where I have to deploy it in order to fulfill the KPIs associated to a network slice with the least cost. That is also related to the service-aware location. If I have a vehicular network slice, then I probably need to put all the network function into the edge. If it's a mobile broadband network slice, I probably get the most out of it by centralizing everything. And I may have further optimization like energy efficiency, so doing that with the least amount of resources, and mobility management. So probably some deployment patterns of DNF may be better for certain mobility management schemes. This is a more practical item, orchestration in practice. This is actually an open source tool provided by Telefonica, which is one of the partners of the project, that is MANO. It is currently implementing the HCNFV proposal. So one of the goals of 5G NORMA will be extending this software, which is currently available. It's open source, you can find it on GitHub, to support all the enhanced functionality we are going to propose within the framework of the project. So to conclude, future 5G network as we see it in 5G NORMA. So we basically build on these two novel technology, SDN and NFV. So they enable network slicing and network programmability. We use network slicing for efficient resource sharing among tenants and service isolation. We use network programmability to enhance the flexibility and the resiliency in order to provide specific KPIs to specific services. Of course, we need to tackle some problem and tackle some challenges. It is the efficient orchestration, how I orchestrate, allocate resources, where I deploy network function for a specific service, how I share those resources among different network slices. That is very important for the correct operation of the network. And the third one, how I design a network function in order to support the logic agent archi scheme as I was presenting before. So all of these three challenges are currently investigated by 5G NORMA, and specifically in the framework of WP5. So with this new concept, we can actually achieve those goals that are enabling new 5G businesses, because we actually improve a lot the flexibility of the network by these two novel concepts. Of course, enhance the network KPIs, because in the process we are actually making the network more efficient, so we can actually get more out of the network. And the third one, which is probably the most important, we can deliver new added value through software instead of hardware, which is easier and more open, let's say, for new improvement also. That concludes my talk. If you have any questions.
Are there more questions from the audience? Okay. Yeah.
You mentioned a couple of terms when you were talking about the STM controller, NDIs and SPIs. Just want you to know, just from my understanding, those the interfaces.
Yes, this is the northbound and southbound interface. You mean? Okay. So the northbound, it processes high-level messages, and the southbound, through some plugins, interfaces to the specific network functions you have. So if you are controlling traffic steering, that will probably be overflow, for example.
You mentioned that you target a real-time migration of functions, maybe to do load balancing, I assume. Is right, or?
No. One of the advantages of this approach, by splitting the logic and the agent, is that you can actually, if you need to reconfigure some part of the network, you can actually leave the network function where you don't need to perform live migration. You just need to reconfigure it by splitting this.
By increasing the processing capacity of a virtual machine.
One side, and
do we have an idea how
by controlling it through the SDMC. So you don't need to. Okay, I need another kind. I need to add another application, another network function to the chain. So that will be critical, because you are actually adding one more network function to the chain. So you need to.
This means you are not targeting a migration of a function from virtual machine to another one. You are targeting to let the virtual machine breathe. Is my understanding correct?
We are also targeting migration, because sometimes you need to migrate network function, but you also have the other option. So you can react to changing condition by reconfiguring the network through the controller.
And do you target their migration of the virtual machine itself? Or?
Yes, for example, for mobility, if, I don't know, high-speed trains, you may need to migrate VNF in different edge clouds following...
Including the virtual machine? The dirty paper migration with the context transfer, everything?
Well, that depends on
the... We have several seconds time.
That depends on the cost trends, yes, actually.
Yeah, but I think there's the super fluidity to actually have one of these projects which is exactly on this VM, really on how to design virtual machines, how to accelerate migration, setup time of virtual machines. And certainly you will not move virtual machines through the network. It's kind of silly. It makes much, particularly if you have a high-speed train, but once it's context transfer, and then the question is how long does it take? Because if it takes 5 seconds, then you don't need to transfer this context.
5 seconds is already challenging.
Yeah, and if it would take 5 seconds, then yeah. But actually, most of these questions are tackled in very much detail by superfluidity. We are also not, I don't know if we are on board or not. Anyway, okay. Other questions? Okay. Because otherwise I would say thanks again. First, Marco.